The melting point of ice is 0 degrees Celsius. During a chemistry experiment, Jill observed ice melting within 2 degrees Celsius of this measurement. Write the range of temperatures that Jill observed. And if we go ahead and take a look at the situation on a number line, it would look something like this. Where Jill observed the ice melting from 0 degrees to 2 degrees. Right? So it'd be the range from 0 to 2, including 0 and 2. So in this situation, what would we have? Well, for our case 1, we would have that our variable t, let's go ahead and first start by defining our variable. Let's say let t be the temperature Jill observed. Alright, so then for our case 1, we would have t is greater than or equal to 0, right? But we would have two inequalities. We would have one going to the right, we'd have another one going to the left. So we have our first inequality here, and they would be connected using AND, case 2. Right? And what is our case 2? It's that t is less than or equal to 2. Right? So if we have these two inequalities and they're connected with an AND, then that means this is the range of numbers that we are observing, Jill is observing that the ice is melting. So let's go ahead and connect these two inequalities using the AND operator. Right? The way that would happen is we would find what's less than t. That's the 0 is less than t. Right? We can go ahead and write this case 1 as or 0 is less than or equal to t. Right? So 0 is less than t. So our solutions to that would be curly brackets t such that 0 is less than or equal to t, and t is less than or equal to 2. Like so. And if we wanted to go ahead and graph it, we can do that. Let's use this inequality here. It's a closed circle on 0, and our arrow is moving to the right, like so. And then we have a closed circle on 2, and our arrow is moving to the left, like so. So for which values are both of these inequalities true? They're from 0 inclusive to 2 inclusive. So we would put a line in between the two. Let's go ahead and move on to the next word problem. We have here Jerome bought stock in his favorite fast food restaurant chain at $70.85. However, it has fluctuated up to 75 cents in a day. Find the range of prices for which the stock can trade in a day. Alright, so it has fluctuated up to 75 cents in a day. Fluctuated means goes up or goes down from its price of 70.85. Okay, let's go ahead and start by creating our variable. Let's say let x be the price of the stock, and if the price is moving up and down 75 cents from the price 70.85, then that means we have an inequality involving an absolute value. We can say x, the absolute value of x minus 70.85, its current price, is less than or equal to 75. So now that we have our inequality, we can define our case 1 and our case 2. Our case 1, we're simply going to remove the absolute value, and we'll get x minus 70.85 is less than or equal to 0.75. In our case 2, we are going to remove the absolute value. However, we're going to flip the sign of every term in the absolute value. So it's going to become negative x plus 70.85 is less than or equal to 0.75. Let's start by solving case 1. So case 1, we're going to add 70.85 to both sides of the inequality. And we will be left with x is less than or equal to 71.6. And then on the right side, we'll subtract 70.85 from both sides, leaving us with negative x is less than or equal to negative 70.15. No, I'm sorry, 10. Now we're going to divide by the coefficient of negative 1, and we'll be left with x is greater than or equal to 70.10. Okay. Notice here that since we divided by a negative number, our sign flips. And what I want to do is I want to rewrite this expression. I'm sorry, I want to rewrite. Which expression do I want to rewrite? Yes, I want to rewrite this expression. So I want to say or 70.10 is less than or equal to x. Okay. So all I did was switch the x and the 70.10, and I flipped the sign. So these two inequalities are equal. And now we can write our solution set. And so what is our solution set? It's curly bracket all x such that what is less than x? It is 70.10. So 70.10 is less than or equal to x. And what is greater than x? It is 70.60 is greater than. So x is less than or equal to 71.60. Curly brackets. So these two are the ranges inclusive of the price of the food at the restaurant chain if it fluctuates by 75 cents per day. Alright, let's go ahead and do the last problem. Kareem is allowed to download $10 worth of music each month. This month he has spent within $3 of his allowance. What's the range of money he spent on music downloads this month? And so we want to go ahead and start this problem by understanding that he's given $10 a month and he has spent within $3 of his allowance. So we don't know if he spent $7 or if he spent $13, but he got close to $10, right? Off by 3. So what's the range of money that he has spent? Well, it would be an inequality involving an absolute value. Right? We would say absolute value of x. Let's go ahead and start by defining our variable. Let x be the amount Kareem has spent. And if we have our variable that x is the amount that Kareem has spent, we can create the absolute value inequality involving an absolute value, stating that the absolute value of x minus 10 is less than or equal to 3. Alright, so now we can go ahead and create a case 1 and a case 2. And in our case 1, we're simply going to remove the absolute value, and we'll get x minus 10 is less than or equal to 3. And in our case 2, we're going to remove the absolute value, but flip the sign of every term inside of the absolute value. So it'd be negative x plus 10 is less than or equal to 3. Let's start by solving case 1 by adding 10 to both sides of the inequality, and we're left with x is less than or equal to 13. And then over here, we're going to subtract 10 from both sides of the inequality, leaving us with negative x is less than or equal to negative 7. And now we want to divide by the coefficient in front of the x, the negative 1, and that's going to leave us with positive x is greater than or equal to positive 7. Right? So in this case, the inequality is flipped because we're dividing by a negative number. And now we have our two inequalities. And these inequalities are going to be an AND. All right? So case 1 and case 2. Because Kareem has spent somewhere in between $7 and $13. Right? So that's what these inequalities are stating. And we are connecting them with an AND operator. So let's go ahead and write our solution set. It's curly bracket x such that, and what is less than x, right? It's this one right here. So let's go ahead and write this inequality as 7 is less than or equal to x. Right? So it becomes clear exactly what is less than x. So all x such that 7 is less than or equal to x, and x is less than or equal to 13. So this is our inequality. I'm sorry, this is our solution set. And what it's telling us is that Kareem has spent an amount that's between 7 and 13 inclusive, meaning including 7 or 13.